Hello everyone and welcome to Halland Tech Week. My name is Eva Hjelmred and I work for the Alexandersoninstitutet at Campus Varberg, and I have the pleasure of welcoming you all here to this session called Smart Building in Smart Cities. This session is presented by the S2C project. S2C stands for Scandinavian Sustainable Circular Construction. It is a project financed by the Interreg Öresund-Kattegatt Skagerrak, focusing on sustainable and circular public construction. As you can see in the logo, there are 3 countries' flags there. So we have partners from Sweden, Norway, and Denmark. And today we are broadcasting from Sweden, and we have prominent speakers from Norway and Denmark. Just to let you know, all sessions during Halland Tech Week will be recorded. So is this session. So it is possible to take part of it afterwards, and also all other sessions. And we do encourage questions. So please use the chat if you have questions, and we will ask them to the speakers. Yes. So our first speaker is Haidar Hosamo. Haidar is a PhD research fellow at the University of Agder in Norway. He started his position in August last year and has the master's degree in science, civil and constructional engineering as a background, also from the University of Agder. Furthermore, Haidar is a lecturer at the Oslo Met University. And today we will hear about digital twins and results from case studies. So Haidar, the floor is yours.
Thank you very much, Eva. I will just share my screen. You can see it now?
Yes.
Great. So thank you very much for the nice introduction. Actually, today I'm going to talk about smart buildings, digital twins, and I hope you will, that will be something interesting for you. And I would like also to thank you for being here in this presentation. As Eva mentioned, I'm a PhD research fellow at the University of Agder. My supervisors is from both universities, University of Agder and Aalborg University. And I'm gonna start by motivation for this work, and then what is important inside a smart building, and how we can use digital twin technology for the application of smart building, including predictive maintenance, saving energy, and occupants' comfort. So to start with, smart building is a building that provides a productive and cost-effective environment. And actually, a smart building is something that supports a green building in enhance indoor climate and occupants' comfort and energy efficiency. So it supports the building in all its phases and in all its components, including structure, system, service, and management. So the important in the smart building is to avoid and reduce damage, achieve energy saving, improve occupants' comfort, and integrate subsystems to control them together. And in this work, we are concentrating on design phase or operation phase of the building, and especially heating, ventilation, air conditioning system, where is it like the heart of the building, and it's consumed more than 50% of energy into the building. But the problem that when we have a lot of data from the building, we have sensors, we have building automation system, but still we don't use this data in the right way. And like facility manager used around maybe 80% of its time just to deal with data and to find and to extract information out of it. So what we really need is smart data instead of big data into the building today, so we can reach a smarter building. And digital twin can be one tool for that, for observation, reasoning, and physical system control. And actually, digital twin, in a simple definition, it's a replication of the physical object by streaming the real-time data from the physical object to the digital one. And then we have the digital representation at the real time of the physical object. But this is just a simple definition. Actually, digital twin is a decision-making tool that will help in people, or help to make smart management of the building and let people interact with their indoor environment and feel more comfortable. So digital twin technology has been applied in several domains, started by NASA and manufacturing process. So there is still a lot to be applied in building sector, including safety and seamless security, enhance building performance, and indoor climate. However, we still don't use the digital twin technology in the right way in construction, or we don't have real implementation of the digital twin into to building, or to make smarter building. And I agree with Ben van Berkel. He said, while we are all using iPhone, construction is still in the Walkman phase. Because if you just open Google and search for Industry 4, you will find a lot about that. I mean, about cyber physical system and Internet of Things. But for construction and building, the fourth revolution, you cannot find a lot about it, and especially how to use digital twin to advance it. So I did a deep literature review actually on several databases, including Scopus Web of Science and Google Scholar. And then, as you can see here, as a bubble is larger, then it has a stronger connection to the digital twin technology. This is based on text mining method. And you can see that Industrial Revolution has like the strongest connection to digital twin technology, while the other tools, or especially smart building, has very small connection to digital twin. And out of this figure and several other figures that it's not possible to show them here, actually we end up to find that we need to connect digital twin to make smarter building. Using digital twin, we need to concentrate on occupants comfort and predictive maintenance, energy consumption, and semantic fault detection. And as I use the digital twin technology, actually, so in my opinion, or how I see it, after I did this deep literature review, it's a combination between building information modeling, machine learning, and human knowledge, actually. So when I say building information modeling, most of people think that it's about 3D modeling of the building. But actually, as you give more information to the model, then you have more dimension. So if you add, for example, time, then you have 4 dimensions. If you add cost, it's 5D. If you add sustainability criteria, then it's 6D. And when it comes to maintenance, it's 7D. So we are in this phase now. We are trying to combine facility management application to machine learning and human knowledge. We have 2 case studies here. Well, the first one is E4 Helsa, it's a part of the University of Agder in Grimstad, and the other one is at Vedderstrand Skola. It's a secondary school in Arendal in Norway also. So in our work, we are using real data from a real building to implement our digital twin model. The first model is for predictive maintenance of air handling unit. So we start by collecting data from sensors into the building, and then we do pre-processing on this data, which is like the most time-consuming part. And then we applied the human knowledge from which is exists in the literature review, which is the rules from experts. And at the end, we can apply machine learning and then build our maintenance plan. I mean, make a new maintenance plan and show the result into P model, and then close the loop to take the new results as inputs for the model. So as you can see here, you'll find that this is our P model. And if I just close it here, then we build like a plugin into P model that can take data from sensors and show them into the beam model. And then we can take this data to start our to apply our rules and machine learning afterwards. So as you can see here, for example, this is one of the faults that has been detected based on the machine learning rules out from the sensors data, where the chiller and heater valve were opened at the same time. So we have heating and ventilation at the same time. And then we apply machine learning over this, so we can predict what's going to happen. And I'll just, so you can see here, we take the reason for every fault that we found into our data. And then we applied the 3 machine learning algorithms, which is artificial neural network, support vector machine, SVM, and decision trees. And I found that wide neural network was the best for this work, but this is still now in testing and training and validation process. What we are trying to do now is to expect if we can find the faults into the system for the next 6 months, so we can build a new maintenance plan based on that. But this is still in the working phase. We are trying to we need to wait a bit to get more data, and then we see if we can predict for the next 6 months. But for validation and training, you can see that it shows a very accurate result in predicting faults. The second work is about the digital twin for energy optimization of air handling units. Actually, we have several types of air handling units, especially when it comes to heat recovery and this area where we have heat exchanger, and if we have like rotating wheel. So yeah, there's different type, and this is basically the air handling unit. So the air is the fresh air come here, and it's come through heater and chiller based on the season, of course, and then it comes to the building and back to the outside. What we are doing, we done that we built a digital twin of this model into the Simulink in MATLAB. So we took every part of the system and we tried to validate it using also artificial neural network. And you can see here that are almost 1 when we are trying to validate this model. And then we need to optimize the system or the air handling unit based on that, where we could apply a genetic algorithm, so we can find what is the best parameters that can make or that can reduce energy consumption into the air handling unit. So this red one, it's all near 1, and then in this area you have the best parameters to use to reduce the energy consumption. The next work is about semantic digital twin for fault detection in air handling unit. Actually, while I was trying to extract data from sensors, building API, and then trying to extract fault of it and combine it with machine learning, and also get data from the building information modeling, it's really time consuming, and you need to spend time and find where this sensor exists and what type of data it's provide and how we can connect. How can we connect it to the rules that we have? So I found that there is a very good solution for that, by which at the end you will be able to write only one line or one query line that will make you able to extract all the data from building, from maintenance record, from sensors, and then you can know that there is a problem into this building, into this sensor and this floor, and this area, and what type of sensor is it. And this framework make it possible to apply fault detection on several buildings, not only on one building, on one air handling unit. So the main aim is of this framework is to make a general system that can detect faults in hundreds of buildings at the same time. So I can show you when I just extract the data from building information modeling to something called QB format. So this is only a part of the file. I just make going here. So you see, this is only a part of it. You can go down too much. There is also several tabs down here. So a lot of information that you need to deal with. And after we make like preliminary application of this model, you can see that we were able to connect, for example, several components only to the first floor. So you see the relation between them is like is a part of first floor here. So if you only also double click on this bubble, you will get more children out of it, and then it will be like you will be able to include a lot of components and connect all of them together, and then apply write this query line to know if there is a fault into this data, and know in which floor, in which part of the building immediately, which will save a lot of time. Another thing is to we are trying to build something called the energy twin for energy consumption into the building, and we have started with that. And you see that we could validate the system, and we could predict how the energy consumption to the building, but it's still like in the beginning phase, so it need to be improved, and we need to find also how we can use it to reduce energy consumption into the building. The last part will be about digital twin for occupants comfort, which is two parts. Actually, the first one is based on machine learning, and we published a survey into two building, which is our case studies about indoor air quality, thermal comfort, and visual comfort, and several other aspects actually. And we are trying also to combine it with the information that come from the building to the building information modeling. So we can use like something called visualization programming to show the result into building information modeling, so you can see into the model where and the people or the occupants feel uncomfortable about the indoor climate. And then we will use machine learning to predict how or where is the place that people may feel uncomfortable to the building, and then we send orders to the system to make adjustment to make better indoor climate. So the second and last part of digital twin for occupants comfort is by building a simulation model. Actually, we are going to use a software called Haidar. So we are trying to build a similar model to the real building first, and then of course real building, I mean here our case studies, and then we will use this simulation model to apply several scenarios for the building, and then we will see how much energy we can save based on these new scenarios and which is the best scenario. And then that could be used in like next building or improve the same building itself. Yeah, so that's all, and thank you very much.
Thank you so much, Haidar. It's really interesting. And I think it's interesting the quote you had from the Dutch architects about all of us are using iPhones, but construction is still in the Walkman phase.
Yes, exactly.
And therefore, I wanted to know sort of what can we do in order to get to the iPhone phase for construction and the university's part. Is this with digital twins? Is this something that is common in education today, in educating the new engineers, for example, that can touch the future?
Actually, no. So this is something very new. And if you try to find like a real project that is, I mean, in construction, of course, that is using a digital twin, so it's very difficult to find that. I myself, I couldn't find that. So we need to invest more in developing this technology, teach it to the new students, and try to use all the new technology to support the advancement in the construction phase. So for example, machine learning is very new, building and information modeling, building management system, and these sensor data from sensors, combine those technology together is something rare. And how also to apply semantic integration between those technology is also still very new. So we need to invest more in this area to move to iPhone phase.
Good, thank you. And I do have a question from the chat, almost as a follow-up to this from Ingrid. Hello, Ingrid. What is the main argument to invest in this technology?
Yeah, actually, maybe the cost of this technology could be high. The reason because you need to invest into the consultant tools and other stuff that is related to the digital twin technology. But if we think about the future, so this technology will save thousands of dollars by avoiding failure into the systems and by avoiding the replacement of the components of the system while it's still possible to use it, and by reaching more sustainable building and or let me see that more satisfy occupants into the building.
Yes. Okay. Thank you so much, Haidar. We will get back to you. And now it's time for our second speaker for today, and we move from Norway to Denmark. Our second speaker is Teddy Sibbern Larsen. Axelsen, did I have? Sorry, Teddy. Teddy is the head of the Danish living lab DOL. Teddy has been part of DOL Living Lab since the very beginning. And today it's a collaboration with over 50 partners working from a bottom-up approach where they want to bridge the gap between decision makers and technology. They use cases that are as close to real life as possible so you can make use of it. And we will hear more about 2 examples here today. So Teddy, the floor is yours.
Thank you very much, Eva, and thank you for the invitation and the opportunity to share some of our work and some of the solutions that we create together with our partners here today. As you just mentioned, yes, my name is Teddy. I'm heading the DOL Living Lab, and I'm also representing what we call the Rebuild Denmark, which is a leading national innovation cluster in Denmark, focusing on buildings, construction work of different kind, meaning the infrastructures between the buildings also. And in that context, we have a strong focus on smart city and hence the work with DOL Living Lab, where we today is a leading living lab in Europe, focusing on intelligent outdoor lighting and other smart city technologies. What I would like to present here today is a short background telling shortly about how the living lab works, and then going more into depth with 2 verticals. One would be the intelligent outdoor lighting as a carrier, a backbone for the smart city. And next, the intelligent traffic light infrastructure and how we are approaching that as another dimension as part of the lab. So we are based in the outskirts of Copenhagen. We have a site of 13 kilometers of road and bicycle lanes. And here in this area, industrial commercial area, we are working with a number of sites where we are activating, enabling companies of different kinds. We have right now close to 50 industry and knowledge partners involved, where we here in a very pragmatic way, from bottom-up approach, build, develop, upgrade a different kind of use cases, solutions that all in all are representing a number of different building blocks. And these building blocks we connect in new ways, we build on top, we put into play in ways that otherwise for the partners here wouldn't be possible. What is important for us here is the smart and sustainable cities. So it is a tech lab where we focus on the digitization, smart city, Internet of Things, kind of things. But it has to be put into play in relation to the urban development and the focus of creating sustainable cities. The way we do it is by testing, demonstrating in scale of 1 together with an ecosystem of industry and knowledge partners. And what is important for us as part of an innovation cluster is that we offer a facility where we can innovate, we can matchmake, we can build cases to present of different kind. So bridging the gap between cities and the industry is what we do to create some more transparency by testing, demonstrating the different kind of components, building blocks, if you will. And that is to improve decision making, to invite the decision makers to come to the facility where we can make them feel, touch, and practice the different solutions, go behind the solutions, look at the data, the systems, and thus assist in building the skills and the newer levels of knowledge for different parties involved, but also to enhance the scalability. Here we can start out, we can connect the dots, we can connect the building blocks, but to serve the ground for how to take the next step. That is also our focus. And not least, this is a neutral ground. So to make people meet, break down the silos, could be either between silos in different departments in a city government, or it could be between different verticals, industries. Here is partners involved in the lab. It's small, medium-sized companies. It's bigger, more international-oriented companies. They are representing different verticals, different service areas in the city, but also horizontals, meaning connectivity or data infrastructure, etc. It's a facility where we invite decision makers, companies, different kind of organizations to make use of the different learnings, the different use cases, and thus we have an international visitor service where we have many pockets of interest from all around. The way we work is in 3 layers, basically. We have a physical layer, different kinds of infrastructure, vehicles, devices that we put into play, connect via different networks, different network possibilities, and then via the application layer, look into the systems, the data it provides, and if we do it well, then we can fulfill the link all the way from the device, the technology itself, and to all the way to the user or the city operation, making use of the different technologies and use cases being put into play. But starting with a key vertical, a first mover element in our cities, I would like to go more into depth with the lighting infrastructure and how we see and have experienced the development within this vertical in terms of maturing as a backbone, a carrier in a smart city. And why is that? Well, we have it everywhere. We have a light point, and whenever we construct the roads, highways, big bicycle lanes, etc., we make new city developments, we put light. So we have a nice infrastructure as a starting point. It's powered and can be connected, it can be controllable. And those are all basics for advancing with this infrastructure, creating a backbone, a carrier or platform where several more services can be provided on top, other than just providing light, and thus being more opportunities for creating value can be made, and even revenue streams for the city can be established. But from our experience and the way we work with the outdoor lighting, we are working through different key steps, and starting with conventional lighting, then it's typically on or off. Either you have light or you have no light. But with the introduction of the LED technology, we're then presented for many new and more opportunities. Turning the infrastructure into an intelligent lighting system where we have connected IoT devices, we can manage it via light management systems. Adding sensors and other devices on top, we can now have a dynamic lighting infrastructure where it adapts more smoothly to the needs, different activities in on ground, whether it's pedestrians or cars, etc. But also we see different models, use cases for how to make even more use of this light point, serving as a key infrastructure point, a smart pole where you can connect fiber or EV charging, make it interoperable with other elements in the city. Not least the biological, physiological aspects, making lighting even more human-centric, or serving different needs that are important for plants and wildlife is also introduced to a higher degree, and that I would also try to touch briefly upon. But the main driver in this context is definitely energy savings. Traditionally, we had on-off light, either full power or no power. But with the having an intelligent lighting infrastructure, we could create lighting profiles, and then depending on the time of the day, we have more or less light. But now with the dynamic approach to the lighting, we have even more energy savings, meaning that we only have full light when we have activity, and any other time it will be at a minimum. The solution providers, the partners being involved, looks like this. They are in the area situated next to one another, and thus we have a wide range of different answers to how to approach the lighting infrastructure in different ways. But basically, it's all about having connected the devices, meaning that we have now the luminaire, the lamp head, as an IoT device, where whenever it's powered and connected, it will do an automatic commissioning. It would tell where it's located with GPS code, with its GPS code position, and upload the data for the device to get started automatically. But on following that, then the opportunity to access each light point and manage it, and grab one or a group of light points and follow how it performs, knowing errors, failures that demand some action. That is one of the first elements. But on top, the asset management part then also becomes involved, meaning that depending on whether there's a local road or a main square or a corridor, then the opportunity to group the lighting with different light profiles, planning the lighting according to the key events, for example, or even the maintenance part is becoming more digitized, if you will. Some of the cases in the lab shows that yes, we have definitely energy savings provided, and what the different expressions here is telling is that yes, having the LED as a light source is providing 50% energy savings, but the dynamic, the intelligent parts on top will serve even more savings, up to 75–80% energy savings. So it's definitely a key driver. But what we experience is that there are gradually becoming more drivers for this type of installation, and I will come back to that. So building on top and moving into the dynamic part of the lighting infrastructure, then we have just completed an Interreg project where we have paid a very strong focus on the dynamic aspects of the lighting, and many of our partners has thus upgraded to many new versions of how to interpret dynamic lighting, and probably have now a collection, a very ambitious collection of many different solutions of such kind in the lab. But what is common for the solution is they are based on different type of sensor technologies. It could be infrared, it could be noise detection, it could be the radar technology, or a video camera technology, or combination of the different technologies to help detect the need for light. And how it turns out in practice is what you see here is some examples where you combine an IR sensor together with a radar, or a noise together with IR. Or in this case here, noise detection again is activating the level of light as an input to the lighting. But what we then, depending on the level of the advancement in the different sensor technologies, we can certainly see not only the counts of activity beneath the land pad, but also the speed, the direction, and that provides data for urban planning needs, where we in real time or close to real time will have data on traffic in the city. What helps a lot also is the new standards coming into play, being able to apply it across light manufacturers, and that is this Saga socket, where it's like similar to our USB in our laptops. This is a standard connection point where you can add sensors or communication nodes to the luminaire, and thus you have across your city a standard plugin where you can add new devices collecting insights on need for light, traffic movement, etc. But it also presents more complexity, greater demands to using the infrastructure right. It can be used for many different purposes: pedestrians, bicyclists, vehicles, more knowledge on traffic patterns, etc. And in different areas of the city, depending on time and day and activity level, then it has many different functionalities. But it is done right. A good lighting experiences with the help of the different types of functionalities. Then what is important is that whatever it does, it has to be a quite smooth transition. So it's not like blinking up and down outside the window or something like that, but have smooth transition with ramp times that is adjusted before and after the vehicle. But the opportunity is also to, depending on the weather, the activity level, the time of the day, then the color temperature can be adjusted, the level of light, the dimming level of the light can be adjusted. And it presents a number of new functionalities, but if it's done well, it can definitely do a great difference in the city with more energy savings, greater comfort for the users, and helps the urban planning and the need for creating certain identities around in the city possible. I will rather quickly go through the multi-functionality, but basically it's about providing the basic infrastructure in the ground with the power cables fitted for the lighting, for sensors, but more importantly also for EV charging, for example, or making sure there is power 24/7 for even provide fiber for example, the 5G infrastructure, etc. But what is interesting when talking about these smart poles and infrastructure points, Then ready-to-use components, building components are been to a higher degree put into play, meaning we have standard components to build this infrastructure with, inside the pole, outside the pole, and in the ground. And thus we have different expressions of how to build your light points based on different modules, where being tailor-made, addressing different needs. But what is also very interesting when we look into the lighting infrastructure and the service it provides is that depending on the dimming level, the color temperature, the use of the light spectrum, we can make it even more fitted to humans, to wildlife, to plants. So we match the color of the sun throughout the day, or the type of light that the sun provides throughout the day, meaning that our trees, for example, in the lower picture here, will be more not light polluted and having an odd way of growing its leaves, for example. Some general reflections is that we have a lighting infrastructure that is a front runner for the smart city as a backbone. It is maturing well. It's ready to use and building components that can be put into play. And scaling is happening across different cities, and more focus on the right use and the added functionalities is needed, and perhaps different tools can help in that direction, meaning, for example, simulations, VR. In the Dull Living Lab, we have just developed a new tool, VR tool, where we can help demonstrate those aspects even further. And not least, the data architecture is still to be matured, meaning that we have different data inputs, but to put them right into use is also a focus point. In my final 2 minutes, I would like to touch upon intelligent traffic lights. That is a new focus point in the lab, where we ask about what do we demand for this kind of infrastructure tomorrow. We have a range of new mobility offers introduced, car sharing, electric bikes, buses, providing more and more data about how full it is, what is behind its schedule, etc. But also car manufacturers are providing more data. So how can we put this into play, and what is asked for? For example, cities, road authorities are asking for this kind of infrastructure to be more flexible, less vendor lock-in, more coordination across technologies, manufacturers, vendors, but the data from third parties and the AR machine learning on top of that is quite interesting in terms of also being able to prioritize more aggressively, if you will, different type of traffic in the city. So what we do in the lab here is that we put the infrastructure into play with the 6 traffic lights, intersections, and different companies are then taking over. And here we then make state-of-the-art solutions where, for example, third-party data are applied into to the traffic lights, being able to be even more intelligent and even more optimized according to the dynamic need for more green light, in some occasions less green light in other occasions, etc. And an ecosystem of different other partners providing different kind of data into the traffic lights are present. For example, here in the lower right corner, the light infrastructure is providing data into the traffic light, and that is an interesting example of how these two infrastructures are merging and possibly generating the synergies between elements in our city that we imagine that a smart city will do. And that's an interesting step forward to to our experience at least. But that is what I have chosen to share with you here today, and I'm very open for questions in this direction. So thank you for your attention so far.
Thank you so much, Teddy. It's really interesting to hear about the work that you do at Doll Living Lab, and particularly about lighting. I have a first question, and that is about the lighting and the possibilities of lighting. What would you say is the greatest gain? Is it the energy efficiency, the money you can save, multifunctionality, or physiology or biological aspects? If you have to choose one.
Well, it's very clear that the energy savings is a major driver here, right? And that is what has been driven the development throughout the last 5 years. But now we see that the use of the different functionalities, technologies that are applied on top, provides other incentives, other key incentives. So it's not only the decision maker within the city working with the light infrastructure that is now interested in this. It's also the city planners, for example, traffic, or the employees working with traffic, roads within the cities are also now a key stakeholder in this development. So it provides a wider spread of different value creation across the departments in the city.
Good, a lot of added value.
Mm-hmm.
Yeah. And just one question, since GDPR is on top of everyone's mind most of the time, how do you work with privacy when you have this kind of systems? Is it a problem, or how do you see it?
Well, it can be a problem, of course, and privacy by design is well required for across many of the vendors, the partners involved. But some of the answers that they provide is that not all detection technologies compromise at all the GDPR aspects, but others, there are a few that do or can do but the processing of the data, edge computing, is some of the answers to this. But one thing is what you do in connection to the individual components, devices they put into play. Another thing is the overall architecture, the infrastructure you build as such, because many new doors, many new points are activated that potentially can be a weak point to compromise. But in general terms, then on a component level, on a device level, then the privacy by design is solved quite well, but there are so many layers and aspects into the security question that has to be addressed, and that is an ongoing development. Yeah.
Thank you. And now we're opening it up for a Q&A, so please ask your questions, and welcome back Haidar as well. And we do have a question from Mana. What kind of information, it's towards Haidar, what kind of information needed to be collected about the building tenants? Could you please elaborate on the privacy issue here?
Yeah, actually, this is a good question. To start doing these surveys about occupants comfort into the building, so we need some critical answers from occupants into to combine them with the data that we have from the building. So we ask them about how they feel about the indoor climate, about the humidity, about their clothes. So about specific thing, how they feel the noise from the building or from the next room to them. So to reach this level, to publish this survey, we need to go through several steps. The first one is to go to NST, which is a Norwegian Center for Research. So you need to get like approval of them. You need first to send them description, what you are going to do, how you are going to publish your survey, in which server you are going to use. You also need to send them the questions. So what are you going to ask people there? And once they agree on it, which takes almost 2 months, then you have to send this survey to the post in every building, like in our case in Ifira Health and Bedrestan School. And then they will give you like feedback. Also, they will send it to head of departments of every building. Also, they will give you another feedback about about your questions, about the survey, and at the end you will be able to send it to people. And also, you are not allowed to publish any information about that, and it should be saved on service that's related to the university, so it's secure.
Thank you. And Haidar, do you have a dream case you would like to follow?
Actually, no dream case, but I need to have more case studies because my next work will be on semantic technology or semantic digital twin. And for this, I need hundreds of buildings. And now you see that the data is like gold. So you need to extract this gold from building. And sometimes it's very difficult to get this data or to convince people to let you or to share their data. So yeah, I dream to have more case studies as possible.
Thank you. And Teddy, the upcoming tests that you are doing at Doll Living Lab, what are you most excited about? You're muted.
Yeah, well, two things is that what I think is quite interesting is, of course, to work with individual verticals, the different service areas within the city, but to see how they are overlapping and the creation of synergies in between the infrastructures is quite interesting. And many of the solutions, the cases we have present in the lab, the data that they generate is often very within their specific, their own systems. But we see more of our players that would like to build across and in that sense, being able to complement different data sets. And that is definitely a next step to mature the data architecture across the different verticals, technologies, components, systems. And I'm guessing that is very much the same when we talk about, well, the inside the buildings, that is a key principle that we touch upon.
Haidar is nodding. And Teddy, you have worked with a lot of different cases and they are close to implementation. Do you have any important lessons in the implementation phase on how to act or how to actually make it something that you are implementing?
Yeah, we can make a lot happen. We can put a lot of technology into play and we can make a lot of interesting data, etc. Right? But to make the good cases, the cases that have the ability to be scaled, we need to put the cases as close as possible into in direct contact with the city operation as possible, so that the real life is connected to real life needs, connected to the work that is done on an everyday level, and being aware of what are the systems, the organization that is tapping into as of now, but also what can then be the potential tomorrow. There's a very fine balance because the cities are not investing into new systems all over all the time. So they are very much aware of how to build on top of what is already being made. Yeah.
Thank you so much. And thank you, Haidar and Teddy, and to all of our participants here today. We have run out of time. You know, when it's a lot of fun, then the time just runs out. So thank you so much for the lessons learned today about smart buildings in the smart cities. And as we said, this session is recorded, so you will be able to watch it afterwards if you would like to. But thank you and have a great day.
Thank you, Eva.
Thank you. Bye.